So friends, we are back with tutorial 12. It is similar to tutorial 11. We have talked about the configuration of one typical numerical overcurrent relay in tutorial 11. In this tutorial, we are going to talk about ground relays. That is the only difference. And how to configure the ground relays in case of an interconnected network. We are not going to take a very difficult or very complicated interconnected network like the researchers are taking a 7-bus system or 11-bus system and optimizing the system for such a network. We are not going to do, because that is going to be very difficult to understand, and we have to enter into some computer algorithm. And to talk in such tutorial classes is not good. See, that can be done only in research while sitting at home and doing that practice on paper or computer. So while we are teaching, we have to take some simple things. So we will be talking of a simple parallel feeder fed from one end. On one side there is source, on another side there is load, and some 6-7 relays. And but we will be talking of different possibilities, because there are parallel feeders. Means one parallel feeder may be off, both may be working, both generators may be on, one may be off. So how you will use the facilities of the modern numerical relay, that we will try to talk about in this particular tutorial class. So going ahead, friends, power system network is the same, nothing different, which we had seen in tutorial 11. Two generators, two generator transformers, two relays on generator side. CT ratio is 1000/1. By typographical mistake, it is not written, but very easily understood, because there is no other thing, no other line going. R1, R2 are those relays. R3, R4, R5, R6 are relays on two parallel feeders. R7 feeds a 132/66 kV 100 MVA transformer. All 7 relays are wired for 3 overcurrent and 1 earth fault scheme. 3 overcurrent, that is the phase relays we have talked about. We are going to talk about the ground relays today. The fault levels are given: 1000 MVA, 700 MVA, 400 MVA, 408 MVA, but they are the MVA levels at 3-phase fault. We are not needing that. We are going to need the earth fault calculations. Therefore, we will need the earth fault current at bus A, B, and C. That we will see what it is. So bracketed figures we are not interested in. Relays are the overcurrent and earth fault relays. It is given that it is 10 to 40%, but not so. Here we have a very modern numerical overcurrent relay, which gives a very wide range. We will see. Both phase and ground overcurrent relay are 7. TMS is 0.25. We don't change it. R1, R2, R3, R4 were voltage controlled overcurrent relays. As far as the phase relays were concerned, ground relays need not be voltage controlled, so forget about it. Excitation currents of all the 3 cities we will need for earth fault calculations. So that is 0.03 ampere per city. Earth fault currents at bus A, B, C are given, and we will assume suitable discrimination margin, that is 0.25 second, and we have to determine the flux settings and time settings of all phase and ground relays. Phase relays we have done, ground relays we will do for the given figure. So going further, as I told you, we have taken one relay REF615 of ABB make, that is overcurrent and earth fault relay of ABB make. it gives, there are about, if I mistake not, some 19 or 23 modules, and it's a very rather, so to say, comprehensive relay. Many facilities are there. All facilities, to talk about all these facilities, we would need hours together. And here we are talking about the short tutorial videos of half an hour, and I am not being able to complete within half an hour too. So we will not talk about all modules, all all facilities. And it is not so that only ABB is making. Siemens is also making similar relay. L&T is making. Isnrerol is making. Cell is making. Right? The Schneider is making. All relay manufacturers are making. The facilities may be here or there different. Right? But they are making, and you can use any relay, not necessarily ABB, because I am not an ABB man. So, but I have to use some relay to talk about. So I am taking Relian version feeder protection relay REF 615. The plug setting 0.05 to 5 for overcurrent. For earth fault, we will see different step. There were only 7 steps. Here there are many steps because each step is of 0.01, and there it was 50 to 200% in electromagnetic and static relay. Here it is 5% to 500%. Start value mult is a special feature we had talked about last time. TMS 0.05 to 1 in electromagnetic and static relays. Here it is 0.05 to 15. Obviously, step here remains same 0.05. And all these 3 things or all other things are available in 6 different groups. That means in one possibility you can have 1 plug setting, in second possibility you can have second plug setting, etc. The operating time delay for definite time curve. If you are using a definite time curve, then there is no inverseness. So there will be no TMS. There will be a fixed time setting, and that fixed time setting is also adjustable, 40 millisecond to 2 lakh millisecond in steps of 10 millisecond. So that is the relay. The operating time curves available in phase as well as ground, both relays. 17 different operating time curves available. You have heard about only normal inverse. In college, in engineering institutes, I have seen that people are teaching only normal inverse. And that too, the teachers and students like to learn that old disk type of relay. Right? All this type of relay is there. The energy meter, analog energy meter, is also a disk type analog energy meter in earlier days. If you go to see a meter today, it is a digital meter, but in earlier days it was an analog energy meter. So Professor Tukaram from IISc Bangalore had come to BVM, our engineering college, and he was trying to, he was given the job. He was told to see the syllabus and give his comments on the syllabi. BVM became autonomous, and therefore they prepared their own syllabi. So in that syllabi, from electrical measurement, he heard the word, or he had seen the word creep of energy meter. Creep of energy meter means when there is no current, when your house is closed, when you are not using any electricity, then meter should not run. With voltage is available, voltage is in any case available, but with voltage alone it should not run. But meter does run with voltage alone. So anti-creep adjustment is required to be given, right? So creeping and anti-creep adjustment was in the syllabus. Professor Tukaram told head of the department, Mr. Rasesh Mehta, because he was knowing him by name. So he told Rasesh, you go to your house and see whether your disk creeps. Huh? Whether the disk is running at your home, there is no disk. How it will run? It is a digital meter. So don't teach those things which are not available in the market. No relay manufacturer is manufacturing electromagnetic relays. No person is using electromagnetic relays. So forget about electromagnetic relays. Here there are 17 different curves. You can see I talked about. I'll not repeat. I'll go ahead. The type of reset curve, minimum definite time for IDMT curve, reset delay time measurement are non-group settings. They are not available in 6 groups. It is only one single group. Directional, characteristic angle and polarizing quantity once again in 6 different groups. Directional means you can make the relay non-directional, you can make the relay forward directional, or you can make the relay reverse directional. Anything you can do, right? And the characteristic, and not only anything you can do, but in one relay, in one case, in one group you can keep non-directional, in another group, in another possibility you can keep it forward directional, and in third possibility you can keep it reverse directional. That is the rather enjoyment, that is the romance of the relay, that is the speciality of the relay. You see, such things were not available in electromechanical world, the old world, and therefore the relays were simple. Relays were not costly, but they were damaging the power system very badly. Power system was not available for a good time. Now power system is available for very good time. Power quality is very good. You will see very good frequency now. So these are all advantages of smart grid. And therefore, you see, students should learn this, teachers should teach this, syllabi have to be redefined, rearranged, because things are different. The world has changed. So this is that. Going further, earth fault, instead of 5% to 500%, it is 1% to 500%. That is 0.01, 10 milliampere of sensitivity is available. Other settings are same as phase over current relays. High set also is available. I double greater than. Very high set, I triple greater than is also available. What we consider in our case here, in our example today, in our today's talk, relay rating 1 ampere and 5 ampere both available, but we will consider 1 ampere. There are 6 groups available in our relay, but we have only 4 possibilities. 2 lines and 2 generators on, 2 generators on but 1 line off, 2 lines on but 1 generator off, and one generator and 1 line are only on. 1 generator is also off and 1 line is also off. So we have only 4 possibilities. So we will use 4 different groups, and how to find out the settings for 4 different groups, that we will calculate, and that we have to feed to the relay, and then we have to properly configure binary inputs to change the setting from one to another group automatically. That means when one line trips, automatically the group will change to group 2. If one generator trips, the group will change to group 3. If one generator and one line both trips, it will go to group 4 automatically. That automatically means you have to configure the binary input properly using the auxiliary switch of circuit breaker. That is what you have to do. You have to do some wiring. But after doing that wiring and after properly configuring the relay, you can be at rest, and power system will be very well protected, will be very well available. Damage to the equipment will be negligible, probably nil, and therefore these relays, these smart relays, are these numerical relays, they call it ID. The ABB is calling it ID, intelligent electronic device. It is an intelligent device, right? जैसे कि हम artificial intelligence बोलते हैं ना, we are talking about artificial intelligence. Definite minimum time for inverse curve we take 40 milliseconds. There are many curves, but right now we will consider only one curve, IC normal inverse. Type of reset is immediate. Measurement will go for DFT. Characteristic angle we will be taking 60 degrees. So this is all what we will take for the given example. So now condition 1, both the generators are on and both the lines are on. Therefore, whatever both generators are generating, and they are operating at full load. So whatever full load they are generating, that is divided into two parts in two lines, right? So accordingly, you have to decide the setting. Plug setting of R7 will be considered based on minimum available in numerical setting. Mind you, plug setting is not decided based on normal rated current in case of first fault. Therefore, because normal rated current 0 is passing. So minimum available is 0.01. So R7 we consider 0.01. There you have to consider 10%, that is 0.1, or 5%. Here 0.01, 1% is available. But CT secondary current is not 0.01 because excitation current of 3 CTs is ZS, so it is 0.1. Therefore, plug setting of R7 in primary terms is 50 amperes. 0.1, 10% of 500 ampere. And for R3, because R3 and R4 are backing up R7. R5 and R6 are directional earth fault relay. The direction away from bus B looking towards bus A, therefore normal current is not passing through R5, R6. Therefore, R3 and R4 will back up R7. So, if I calculate for R3 and R4, then my calculation goes like this, that 61.9 ampere is the plug setting of R3, 1.3 divided by 1.05 of plug setting of R7. Now, 61.9 if you take to secondary, because CT ratio is 1000/1, it is 0.061. And if you deduct 0.09, that is requirement of excitation current of CTs, it takes me to minus 0.02 ampere. Now you cannot set the plug setting at minus 0.02 ampere. Therefore, minimum 0.01 ampere once again I can consider. But I am thrown into another trouble. I am thrown into another trouble, that R3 and R4 are backing up R7 also, but R3 is backing up R6 and R4 is backing up R5. Therefore, if you keep R3 and R4 at 0.01, then R5 and R6 have to be kept. Plug setting has to be less than R3 and R4. Now, less than 0.01 is not available. So, you are forced to set the plug setting of R5 and R6 at 0.01, and R3 and R4 you will have to accordingly calculate. And if we so calculate, our calculation comes like this, that the plug setting of R3 and R5 and R6 is 0.01, and therefore R3, R4 is 0.04, right? R1 and R2 should be more than 1.3 divided by 1.05 of 0.04. That comes to 0.08. And now I set instantaneous for I double greater than I use the formula 100B, 100 minus A. So let me calculate 100B. 100B means what? For R7 I am telling. R7 means fault current at C. Fault current at C for this earth fault is 4445. So 4445. Let me check up. 4445. So 4445. That 4445. 132 by 6 is for R7. It is hard because on R7 transformation ratio is there. So divided by 2. So that gives me 2222.5. That is the current passing through R7 for the bus fault at C. That is B. B, but in secondary terms. So I have to divide this by 500. So that gives me 4.445. Right. So that is the current. So now 100B. So this is into 100. That takes me to 444.5 divided by 100B upon 100 minus A. A is, I am assuming 10% overreach for instantaneous unit. So upon 90 because 100 minus 10 is 90. So my setting for the instantaneous setting is turning out to be 4.93 ampere. It is turning out to be 4.93 ampere, but I have set at 2.6. I have set at 2.6. So I don't know, there is some error made in this calculation. But any case, whatever I said, for the fault current that is coming here, that is 4445, 3288, if I say 3288, if I say, right, sorry, 3288, if I say 3288 for bus B. So 3288 by 500, 3288 by 500, 3288 by 500, 3288 by 500. So that is 6.576. That is in any case more than 4 also, right? So R7 is going to operate instantaneously for the fault at earth fault at bus B, because earth fault at bus B and after breaker 7 is more or less same. So what is my point is R7 TMS is given 0.25, but time of operation I have not to calculate. Time of operation is instantaneous. So it is 0.04. So time of operation of R7 is 0.04. So I go with that. Time of operation of R4 is 0.04. With that I have to go. So if time of operation of R4 for 3288 is 0.04, R3, R4, R5, R6, R1, R2, I double greater than I'm blocking. Top of R3, R4 is 0.29 because I have to add 0.25 to that, right? Fault current through R3, R4 is 3288 by 2 because two lines are there now working. So 1644. And secondary is divided by 1000, 1.644. If I deduct 0.09, it is 1.554. So 1.554 divided by 0.4. 1.554 divided by 0.04, sorry, 0.04, 1.554 divided by 0.04, that is 38.85. So 38.85 PSM I cannot take because IS 20, beyond 20 it is constant. Minimum time is there. So log 10 20 into my time requirement is 0.29 divided by 3. So my TMS of R3, R4 is 0.125. So I select 0.50. But once again, I am thrown into same trouble. If I select 0.15, my dear friends, if I select 0.15, if I select 0.15 for R3, R4, then R5, R6 has to be less than that because R3 is backing up R6. So if R3 is 0.15, then R6 is less than 0.05, which is not available. Therefore, I will have to select R5, R6 at 0.15. Sorry, 0.01. R5, R6 I have to set at 0.01. But R3, R4 I cannot set at 0.01. Because it is coming out to be 0.01, you can see, because the secondary equivalent is 0.061, right? Secondary equivalent current of that is 0.061 because 656 is passing, right? The TMS of R3, R4, I found out TMS of hence TMS is 0.4, but as minimum available is 0.05. Because if I select for R3, R4 as I have calculated 0.15, I cannot select 0.15. I will have to, because if I select 0.15, then R5, R6 is 0.0. 4, which is not available. So if I select R5, R6 0.05, then R3, R4 will be higher than that with reference to that. Right? I have to calculate the time of operation of R5, R6 at 0.25 to that, and based on that I have to find out TMS. So that TMS comes out to be 0.2. And if I calculate for R1, R2 higher than R3, R4, because R1, R2 is backing up R3, R4, it comes out to be 0.35. So R7 is R7 is 0.05. Sorry, R7 is instantaneous. R5, R6 is 0.05. R2, R3, sorry, R3, R4 is 0.2 and R1, R2 is 0.35. That is what I'm finding. Now condition 2, single line contingency. Now when single line contingency means what? Both the generators are feeding only one line. So R7 does not make a difference, same. But R5, R6 will be different. R5, R6 plug setting, you can keep 0.01. You had kept 0.01 in earlier case also. No problem. But R3, R4, you had to back up R5, R6. So that you had to go for 0.02 or something like that. Yes, right? What you had to go for? R5, R6. Let me check up. In earlier case, R3, R4, you had to go to 0.2. From 0.05, you had to go to, sorry, TMS. The plug setting I tell. Plug setting what? Plug setting was R3, R4, 0.01, but I could not keep 0.01. I had to go for 0.04. So R4, R5, R6 was 0.01, but R3, R4 had to go for 0.04 because R3 is backing R4. Sorry, R3 is backing up R6. But here there is one line, there is no backup. So no question. So in condition 2, R3, R4 also I will keep 0.01. So I will be able to make the relays more sensitive. And when fault occurs, they will operate faster. R1, R2, 1.3 divided by 1.05 of 0.01, no doubt, considering excitation, current, etc., it is 0.04. TMS of R5, R6, 0.05. R3, R4, 0.15. Based on only R7, right? And TMS of R7 you will have to calculate because R7 will not operate instantaneously because now one line is off means fault currents will no, fault current will not change because both generators are on, so it is operating only instantaneously, right? But based on that, the R3 and R4 is 0.01 and R1 and R2 is 0.04. R5, R6 is 0.05, R3, R4 0.15. R3, R4 you could keep 0.15 because it is nothing like backing up. In earlier case, you had to check up backing up and therefore R3, R4 was probably 0.2. Here it is 0.15. So faster operation is possible. TMS of R1, R2 based on same principle 0.3. Right. Similarly, if you go for condition 3, that is now both the lines are on, but one generator is off. That means only one generator is feeding two lines. That means current of one generator is divided by two parts. And you can use the proper binary input because there are 16 binary inputs in the modern relays, modern numerical relays, and they can be configured for many functions. So I can use this binary input for group changing. So group from 1 to group 3, that is third group. And third group settings are like this. They can be because R7 does not change. R3, R4 will be 0.2. It will reduce because now only one generator is feeding. R5, R6 does not change because they are directional relays. R1, R2 will be lower because R3, R4 are lower. I double greater than I am blocking for all relays but R7. Top of R7 I have to find out, but that is instantaneous. Top of R3, R4. And therefore TMS of R3, R4 is 0.15. TMS of R5, R6 is 0.05. Same R1, R2. Accordingly, I can calculate. So this is, I mean, this Condition 4 is one generator is off and one line is also off. So there R7 does not change, right? But the R3, R4 will change. R3, R4 will change 0.01 ampere. R3, R4 will 0.01 ampere because only one line. So there is nothing like R3 is not backing up R6 because that line is off. So R3, R4 is 0.01, R5, R6 is 0.01, R1, R2 more than R3, R4, that is 0.04. Similarly, the time settings, right? And all these settings I can summarize, which I had summarized in earlier case. One condition, second condition, third condition, fourth condition, plug setting, characteristic curve, TMS, what we are doing, start value mult, high set I double greater than, characteristic curve that is using, time setting for I double greater than, directional feature for which relays do you want, for which you do not want, and characteristic angle. You can go through this. You can try for yourself all this. I only summarized. You can calculate physically and check up whether what I have calculated is correct or not. That is very important exercise, and that is how you will learn, right? Because these things you have never done. Such calculations you have never done in any of the engineering institutes, and very rarely done in industries also, because industries are also giving work to the consultants. You see, all electricity companies are giving work to the consultants. Consultants are MTech PhD people. They calculate and they give to the engineers and they set the relay accordingly. And फिर कुर्सी पर बैठ के आराम करते हैं. Whenever there is an alarm, they will just get up and will see what is wrong, and then they will take actions. Otherwise, setting nobody is worried about. Setting nobody is worried about. But you have to worry about the settings because every now and then tripping is occurring. Means there is something wrong with the setting. So if you know the calculation of setting, you will be much better. Uh, it's okay if it is an electricity company, it is half government. But if it is an industry, they are seeing you, they are seeing your performance. So there, your knowledge uh, will 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 be lot. I mean, your knowledge will be considered a lot. It will have a value. So please try to calculate all this that I have summarized. And with that, my friends, I come to an end with the tutorial. I keep on reminding you that do not forget the word adapt me. Go to YouTube and search for adapt me. See all my videos. Subscribe for adapt me. Like my videos, share my videos to as many people as possible, because this is free sharing of knowledge. And knowledge, if you share, it will increase in you. When I am teaching, whether what you are understanding that you know, but I am certainly, my knowledge is day by day increasing. So if you share the knowledge, it will increase in you. So please share these videos. It should go to lakhs of people, 2 lakhs of people, 10 lakhs of people. When I'm teaching in institute, I'm reaching to 60 students. Here I'll be reaching to 60,000 students, 6 lakh students, or 60 lakh students. So please share. It is you who are going to be my ambassadors, right? So with all that, with all these things, thank you everybody. Thank you for being with me. Thank you for giving time. When you are hearing the video, my dear friends, you need not hear the video 45 minutes together. Hear for 15 minutes and pause. Next day or in the evening for another 15 minutes. Third day another 15 minutes. It is easy to hear the videos, right? So hear the video fully. You will learn a lot. I can give you guarantee that after 150 of my videos on power system protection, you will be expert on power system protection. So thank you, my friends, and good day to everybody. I end my talk